Hello students, welcome to this session. Today we have solved this paper. The paper came at 11 o'clock and it is around 12:15 and I'm doing that analysis. So the physics analysis of NEET test 64, and the paper was an okay one. I find only one question to be tough, but there are many medium questions which are not that easy for everyone, and 16 were easy. So I regard this paper not as tough, but it would be quite lengthy as compared to the previous 2-3 tests which were actually very easy. So here again I'll say a score of 130 plus would be good for an average student, but for a good student again 160-165 plus must be what you are looking for. So let's see what is in the paper. Plus one more thing, on your request I am now decided to send the PDF of this paper to first 50 of the students who will fill their details in the type form attached in the pinned comment. So that's a type form, it's asking some question plus your contact details. Just fill them up, I'll take the data and I'll send it to you by the evening or by the night. So do that fast, because after the 50 students it won't be available. Okay, so just an experiment. So I'm sending this PDF, and if this experiment succeeds I would also be sending the PDF of the unsolved papers from the next papers. So let's see what is in the paper. So let's start the paper. See the question number 1. 1 milligram radium has 2.68 into 10 to the power 8 atoms. Okay, its half-life is given. How many atoms will disintegrate from 1 milligram of pure radium in 3 to 40 years? So 3 to 40 years, you can directly say it is 2t half. So 2t half means 3/4 will decay, 1/4 will remain. So 3/4 will decay, therefore 3 by 4 into 2.68 into 10 to the power 8 atoms will decay. So if you do this, this comes out as 0.67. So 3 sevens are 1, 2, 3 6 are 18 and 2 20. So 2.01 into 10 to the power 8 atoms. So we'll go for option B. That is the most appropriate out of these. So it's the first question. Next, electron in hydrogen atom first jumps from third excited state to second excited state. Third excited means fourth, second excited means 3. Then from second excited to the first, that is from 3 to 2. The ratio of the wavelengths emitted in the two cases is, so first, in the first one, 1 by lambda, you can write it as R, 1 upon 3 square minus 1 upon 4 square. For the second one, you will have the lower one is 2, so 1 upon 2 square minus 1 upon 3 square. So if I take the ratio, I have to take the reverse ratio because I want lambda 1 is to lambda 2. So that would be 1 by 2 square minus 1 by 3 square upon 1 by 3 square minus 1 by 4 square. So it is 1 by 4 minus 1 by 9, that is 5 by 36. This is 1 by 9 minus 1 by 16, that is 7 by 144. So it is 5 into 144 upon 7 into 36. 36 4s are 144. So you have 20 by 7. So the option D is the appropriate one. So simple calculative question for you. Not tough, simple calculation. Next. 2 blocks of 10 and 30 kg are placed along a vertical line. If 10 kg block is raised through a height of 7 cm, the distance through which the other mass should be moved to raise the cm by 1. So what we will have, 10 is raised by 7, so let's say 30 is raised by y, divided by 10 plus 30, that is 40, that should be equals to 1 centimeter. I just used delta y cm is sigma mi vi delta yi upon summation of total masses. This is the result I am using. So what I get, 70 plus 30y is equal to 40. So 30y comes out to be minus 30. That means y is minus 1. That is 1 centimeter down. So we'll go for option B. Now, next one. Fourth. A body of mass m1 moving with an unknown velocity of v1 I cap undergoes a collinear collision. That means 1D collision with a body of mass m2 with velocity v2 I cap. After the collision, both moves with velocity v3, v4 respectively. If m2 is half of m1 and v3 is half of v1, then v1 is okay. So undergoes a collinear collision. So we are not given anything. So what I can write, m1 v1 I cap plus m2 v2 I cap, because it's a collinear, its collision momentum will remain conserved. That would be m1 v3 I cap plus m4 v4 I cap. So this I cap things goes, I can directly write this m1 v1 thing. Okay, so because m2 is half of m1, I can write m1 v1 plus m1 by 2 into v2, that is equal to m1 into v3. V3 is v1 by 2 plus m1 by 2 into v4. That is what we have got. So what is the value of the v1 now? So the value of the v1 will be, take it here, it will become m1 v1 by 2. There it will become m1 by 2 common v4 minus v2. So this goes, so v1 is v4 minus v2. That is what we are getting from the options, so D. Next, the speed of a particle moving in a circle of radius r 2 meter varies with time as this. So speed is changing, non-uniform circular motion, t is in second, v is in meter per second. Find the net acceleration, so AC and AT. So first of all, AT is simple rate of change of speed, not velocity, that is 2t. So value of AT at 2 seconds, you can make it out, is equal to 4 meter per second square. This is AT. Okay, now what would be the speed? Because v is equal to t square, at t equal to 2 seconds, the velocity will be equals to 4 meter per second. So centripetal acceleration is v square by r, that comes out as 16 by 2, that is 8. So now what is the net acceleration? That is AC square plus AT square, because both are perpendicular, one is radial, one is tangential. So 64 plus what we have, 16, so it comes out as root 80 meter per second square. So out of the available option, we have got this option at A, so go ahead. Next, an electric fan has a length, blade length has 30 centimeter. If the fan is rotating at this speed, the acceleration of a point at the tip of the blade, so that acceleration would be what you can say, omega square r. So omega is 1200 rpm. Rpm means 2 pi rotation, 60 seconds in a minute. 2 pi by 60, you know that conversion, into 0.3. So what you have got, this is 20, so 40 pi, so 1600 into pi square into 0.3. So what it becomes, 160 into 3, 480 pi square. And pi square is approximately 10, so 4800, close to this, so 4740 meter per second square. I can go for it. So this is now 6th. Next one, 7th one. In the circuit diagram shown in figure, the potential of the point B, C, D are respectively. Okay, so this is ground marked here. Okay, so what we have, this is ground, so I can directly say the potential of A would be 12 volt and the potential of D would be 6 volt. So okay, we have participants with B, C, D, so D is 6 volt, so these two options are rejected. Okay, so now we are left with, we have to check whether it is 11 or 12. So definitely there will be some current flowing, so it won't be 12, because if no current flows through one, this all would have been at same potential. So I can directly go for this what we have, 11 volt, 9 volt, 6 volt without solving anything. But let me solve also. This is 12 and 6, that means the drop is of 6 volt and this is total 6 ohm. So current is 1 ampere, so 1 ampere flows through 1 ohm, so drop would be 1 volt, so this would be 11 volt. 1 ampere flows through 2 ohm, drop would be 2 volt, so it would be 9 volt. So 11, 9 and 6, so it's an easy one. The figure looks interesting, but the question is not that tough now. In the circuit shown in the figure, V must be, okay, again a similar profile. Current is 5 ampere through this. Okay, so 5 and 6, we can say this is 30 volt drop is across this one. Okay, and because it is short circuited, and this point is short circuited. Okay, not short circuit, I need to check again. Let's say this is A, this is B, so this one is B, this is C, so this one is C, and let's say this one is D, so this one is D. So I can redraw it. Between A and C, I have this 4 ohms. Between C and D, I have 20 ohms, and also I have between C and D 100 ohms. I have between C and D whatever 20, 100 and also 25. So these three are in parallel. Okay, and between D and B we have 6 ohm. Okay, and this is 5 ampere, so this will be 5 ampere, this will be 5 ampere. So 5 6 are 30 I calculated, 5 4 are 20 I calculated. Now this is 5 going through this combo. What is the combo? The combos are would be 1 by R is 1 by 20 plus 1 by 25 plus 1 by 100. LCM will be 100. So it is 5 plus 4 plus 1, so 10 by 100, so R comes out as 10. So 10 into 5, that would be 50. So 50, 30, 20. So the total drop what we will have, let me again calculate, 50, 30, 20, that is 100 volt, option B. Next, the current through an inductor of 2 Henry is given by this. Then the voltage across the inductor, we know the voltage across the inductor is minus L di by dt, that is what we remember. So this is minus L di by dt. So what we have, L di by dt. So d by dt of t sin t. So L is 2. Now t sin t. T sin t, first taking t common, t out, so differentiating sign would be cos t. Then taking sin out, it would be 1. So the answer would be 2t cos t plus 2 sin t. Minus sign is just for polarity, so value would be 2t cos t plus 2 sin t. You can go for option B. So it is minus 2. No point in writing it here. You can directly say this is the answer. Next one. 10th. Wire is bent to form a semicircle of the radius A. The wire rotates about its one end with an angular speed omega. Axis of rotation is perpendicular to the plane of the semicircle. Okay. In the space, a uniform field B exists along the axis as shown in figure. Then the potential difference across P and Q is equal to. So again, whenever you are calculating this, it's equivalent to a rod like this. And let me again take the pen. So this would be equals to 2a, and a rod rotating about its end. You know this, how to calculate this. The way just go at a distance x, take a small element dx. Its velocity v would be omega x. So EMF in it would be b vl omega x dx, and integrate it from 0 to what we have, 0 to 2a. So what you will have, b omega, and this would be x square by 2. So 2 common, that would be 4a square minus 0. So it comes out as 2b omega a square. So it is 2b omega a square, that is a magnitude. Now the potential difference is 2b omega square a square. That is what you are needed. Now it's your task. Tell me P will be at higher potential or Q will be at higher potential. That's up to you. Okay, that option is also given. So definitely that is not marked, so that you have got your answer if you are smart enough. Next. 3 point charges 2q, 2q minus 4q are placed at the corner ABC of an equilateral triangle ABC of side x. The magnitude of the electric dipole moment of the system is. So what we have, equilateral triangle. Now let me take the pen again. Okay. It's an equilateral triangle ABC. One is plus 2q, one is plus 2q, and this is minus 4q. So you can take it as 2 minus 2q's divided into two parts. This is one dipole, and dipole moment always point from negative towards positive. So this would be one dipole, this would be another dipole. Both are having an angle 60 degree. So if this is P, this is P, the P net would be the vector sum that I can directly write as 2p cos of 60 by 2, because both are equal in magnitude. So 2p cos 30, that is cos 30 is root 3 by 2, that is root 3p, and p is 2q into x. So what we get answer as, 2 root 3 qx. That is the answer D. You can directly write. So this is a very common style question, H2O analogy, that you generally take. We have taken that only. Next one. Which one of the following is true about linear isotropic dielectric? Okay. Induced dipole moment of the linear isotropic dielectric is opposite to the direction of external electric field and proportional to the field strength. Induced dipole moment of the linear isotropic dielectric is in the direction of the field and proportional to the field strength. Induced dipole moment of the linear isotropic dielectric is perpendicular to the direction of the external field proportional to the field strength. Induced dipole moment of the linear isotropic dielectric is independent of the direction of the field and the field strength. So just remember, linear isotropic dielectric induced dipole moment is in the direction of the field and is proportional to the field strength. Just remember this. It is in the direction of the field and it is proportional to the field. Just remember this fact that the linear isotropic dielectrics are those dielectrics in which induced dipole moment is induced in the same direction of the external field and is proportional to the field strength. So just remember this. Again, I am telling you. Okay. So this was your question number what we had. This is question number 12. So we have done 12 questions now. Now the 13th one we will take. Now this is the gravitation one. A planet revolves around the sun in an elliptical orbit. The linear speed of the planet will be maximum. You remember, closer the planet to the sun, faster it moves, farther it is, slower it is moved. So maximum speed would be when it would be maximum close, that is at point A. So go for A. Minimum would be at C, maximum at A. Next. The radii of the planets, two planets R1, R2 are R1 and R2, and the densities are this. If G1, G2 represents acceleration due to gravity at the surface, then we write G at surface. Let me take the pen. G at surface U, if you remember, it is 4 by 3 G rho pi R. So this GS is proportional to rho R, if you remember. So then G1 by G2, you can directly write it as rho 1 R1 upon rho 2 R2. That's an easy one if you remember this form. You can get it from Gm by R square, and writing M is equal to 4 by 3 pi R cube into density. So you can get that. So this is D option. Again, an easy one if you know that. Next. 150 joule of energy is incident on 2 meter square area. If Q reflected is this, coefficient of absorption is 0.6 and the amount of energy transmitted. Similar question is asking again and again. So reflected is 15, absorbed would be 0.6 into 150, that means 90 joules. So 90 and 15, 105 is gone, so the transmitted one would be 45 joules. So again, it's an easy one for you. This is 45 joule. Next, a thermodynamic system is taken through the cycle ABCD as shown in the figure. Heat rejected means given up by the gas during the cycle is. Okay, so you have to find the heat rejected by the gas during the cycle. Okay, so what we will have to find out the heat rejected. So here, first of all, let's check the process. First, A to B is isobaric process, so in it heat would be gained. So QAB would be what we can write NCP delta T, that is TB minus TA. Okay, so NCP TB minus TA. So whatever we can write, let's say if this temperature is T0, I can say this would be 3 T0, and I can say this would be 6 T0, and I can say this would be 2 T0. It is proportional to PV. So what we can have, this is 2 NCP T0 and it is positive, so it is not rejected. Now QBC would be NCV delta T, that would be 3 T0. Okay, this is again evolved. Now QCD, here it will give down how much energy it will give, NCP into minus 4 T0. So this is -1, and QDA, that would be equals to NCV into what we have, minus T0. So this is also -1. So now if I have to find the heat rejected, I need to find the value of CP and CV, otherwise I can't do this. So this is not given mono or dia, so I am understanding it is meaning net heat rejected, that would be equal to the net work done in the cyclic process, that is equal to the area. That is what you can do, otherwise you cannot get the answer. So net work done is negative, so heat would be rejected net. So net heat rejected is area, that would be equal to this gap is P, this gap is 2V, so 2 PV. So the question interpretation is this. Otherwise normally heat rejected means the amount of heat only rejected, heat absorbed means only absorbed, and net heat should be the word term used, but as per the question it is meaning is net heat rejected, so we'll go for option A. Next, IIT has asked many such questions where this demarcation is very crucial, and they have asked questions with the same language, heat rejected meaning only heat rejected and heat rejected meaning net heat rejected. So we can't help, we have to try for this. If heat absorbed is given, first go for heat absorbed. If heat rejected is given, first go for heat rejected, then if the option doesn't come, go for net heat. The COP of a refrigerator is 5. Temperature inside the freezer is -20. The temperature of the surrounding in which it rejects heat is. So simply what you know, this COP alpha is QC by W, which you write as QH minus QC. So taking the analogy, you can write it as TC into TH minus TC. So what you have, TC is 253, I suppose, TH minus 253. So what you have, 5 TH minus 253 into 5. So 253, 5 3s are 15, that is 6, and then 1265, that is equal to 253. So 5 TH is, you can write as 253 into 6. That would have been better, I have just solved it. Okay, but you can write it like this. TH would be 253 into 6 by 5. That would be more comfortable for me. That is into 1.2. 12 3s are 36, 12 5s are 60, 63, 12 2s are 24, 24 and 6 30, 303.6. So that comes up approximately as 31 degrees Celsius. So go for option D. Next one. A charged particle is moving in a uniform magnetic field in a circular path. If the energy of the particle is doubled, the initial radius of the new circular path will be. Okay. So what we have, we know R is mv by qb, which you in terms of kinetic energy you write at root 2 mk by qb. So you know R is proportional to root k. So kinetic energy is doubled, that means the radius would be root 2 times. So go for root 2r. It's an easy one. A similar question have been asked in NTA test before, not exact same but on the similar profile. The magnetic field due to current carrying circular loop of radius 6 cm at a point on axis at distance 8 cm from the center is this. What is the value at the center? This type of questions are again and again being asked. So first of all, B at center you know is equal to mu naught I by 2r. Okay, this is what you know. And B at axis you know is equal to mu naught I r square upon 2r square plus x square to the power 3 by 2. Putting this value, so this is B at axis at any point. So if I take the ratio B center upon B at axis, so this mu naught I thing goes, this 2 thing goes, what will remain is This will be r square plus x square to the power 3 by 2, and it would be r cube, I suppose. Yes, this would be r cube remaining. So putting the values now, r square is what you have, 6 square, this would be 8 square to the power 3 by 2. Units would be same, so I'm not converting anything, so it would be 6 cube. So 6 square plus 8 square, that is 10 square, that is 10 cube by 6 cube, that is what you have, 1000 upon 216, I can say. So this is b at center upon b at axis. So what would be b at center now? It would be 1000 upon 216 into 54. So 54, if you take, this is 4 times, so 4000 by 4, that is 250 micro Tesla. So we'll go for option D, that is the appropriate one for us. Now the 20th question now. Two short bar magnets, dipole moment m and m root 3 are joined at right angles to form a cross as depicted in the figure. The value of theta for which the system remains in equilibrium in uniform magnetic field is. So for system to remain in equilibrium in a uniform magnetic field, what should I say? The torque on the first one would be m cross b would be like this. I will write like this. For the second one would be like this. So both must be equal. So what you have, the first one is mb sine theta. The second one, because it is right angle, this would be 90 minus theta. So that would be root 3 mb sine of 90 minus theta. So what you get now? You get this 10 theta as root 3. 10 theta is root 3. That means theta should be equals to 60 degree for sure. So go for option C. Next. Small body is dropped from a rising balloon. A person A stands on the ground while a person B is on the balloon. Choose the correct statement immediately after the body is released. Okay, so it's a relative one. So rising balloon. So that means the balloon was rising. So it was going up with some velocity VB. This is the person in the balloon and you have dropped. Dropped means the body's initial velocity, it will carry the inertia. Because of inertia, it carries the velocity history. So it will, in the ground frame, for the ground person, it will first go up and then it will go down. So A and B both feel that the body is coming down. No. For the person on the ground, the body first goes up. So A feels the body is coming down, B feels the body is going up. If A feels that the body is going up. So initially for the ground person, it seems the body is going up, and for the balloon one, it will straight away go down because of the gravitational acceleration. So go for option D. Very good question. It is just asking what happens when it is just released. It is written immediately after the release. Okay. Next one. The trajectory of a projectile in a vertical plane is this. XY respectively horizontal vertical distances, the maximum height attained by the particle and the angle of projection from the horizontal. So going by this, what we can write, if I compare it, I had that equation as y is equal to x tan theta minus gx square upon 2 u square cos square theta, that I remember. So comparing this, a is equals to tan theta. A is equal to tan theta, so theta is equal to tan inverse A. So the first answer. Now for calculating y maximum, it would be better if I differentiate this whole expression, because going by the other way would be more tricky. So if I do dv by dx, that will come out as a minus 2bx, that should be equal to 0. So that would be when x is equal to a by 2b. So at that point, that y max would be what I will have, a into x. X is what? A by 2b minus bx square, that would be a square by 4b square. This is 4b square. So what you get now, a square by 2b minus a square by 4b, that comes out as a square by 4b. So you can make out y max is equal to a square by 4b, and that first thing you have already been done. So go by option C, that is the appropriate one. Next, you have a uniform rod of length 0.1 meter, mass 2 kg attached to side support at O as shown in figure. It is in equilibrium due to upward force T acting at P. Assume the acceleration to be due to gravity to be 10. The value of T is. So it is just assuming that this distance is 1 meter. I am assuming this thing. And because it is uniform, mg would be acting like this at half a meter. So for equilibrium torque balancing about O, mg into 0.5 must be equals to T into 1. So T must be equals to mg is 20. 20 into 0.5. That comes out as 10 Newton for us. So the option is D1. Okay, next. A man stands on a weighing machine kept inside a lift. Initially the lift is ascending with the acceleration a, due to which the reading is a. So because it is going up with acceleration a, so weight would be greater, the w would be mg plus a. You know this. Now the lift descends with the same acceleration and the reading is 10% of initial. So when it descends, that w dash would be equal to mg minus a. and this is 10% of initial, that is 0.1 times mg plus a. So this m and m goes, what you have, g minus a is 1 by 10 of g plus a, that is how you can write. So what you will have, 9g by 10 is equal to 11a by 10, this goes, so acceleration comes out as 9g by 11, so the option number B would be the correct one. Next, if the half-life of a radioactive element is 10 hours, its average life, as you know, T half is equals to tau ln2, so tau is equal to T half upon ln2. So 10 upon ln2, that is 0.693. So what we will have, it is definitely greater than 10, but it won't be 20, it would be lesser than that. So do this, it would be 14.4. This would be approximately 14.4 hours, you can calculate. So this is 14.4 I can write. Next, at some instant the ratio of the amount of two radioactive element is 2:1, okay. Half-lives are 12 and 16, then after 2 days the ratio of the amount of the two substances, okay. So 2 days means 4t half, it means 3t half. So this was 2:1, so let's say that was 2 and naught, that was n naught. This 2 and naught, 4 half-lives have passed, so it becomes n naught by original was by 16, that is n naught by 8. Here 3 half-lives have passed, so it will become n naught by 8, that means their number will be same, 1:1 now. Next, the simple harmonic motion of a particle is given by this, then the location of the particle from its mean position at time 1 by 8th of a second. So first of all, what is the time period? That is 2 pi by omega, omega is 2 pi, that is 1 second. So this is t by 8. So you know 0 to t by 8, if it is starting from x equal to 0, it's clear from the expression. We know at t by 8, it reaches a by root 2. That is the standard result, you know. You can put the value also in the expression, t1 by 8, 2 pi by 8, sine of 2 pi by 8, sine of pi by 4 is 1 by root 2. So it would be a by root 2, so easy one for you. 28. The xt graph of a particle undergoing SHM is shown below. The acceleration of the particle at 4 by 3 seconds. Okay, so first try to write it as a mathematical function. If I write it, amplitude is 1, starting from 0 going positive, so it would be sine with phi 0. And what is time period? Time period is 8, so omega will become 2 pi by 8 into t. This is the way. So now, what is the acceleration of the particle at t equal to 4 by 3 second? Okay, the xt graph is given. So what would be the acceleration of the particle at t equal to 4 by 3? So what is x at t equal to 4 by 3? First of all, that would be equal to 1 into sine of 2 pi by 8 into 4 by 3. So what we get now, 2 goes sine pi by 3 is 60, sine 60 is root 3 by 2. So what would be the acceleration? Acceleration is minus omega square x, omega is pi by 4, I can write square, x is root 3 by 2, so it comes out as minus root 3 pi square by 32. So we'll go for option D. So just you have to write the function and do this, not very tough, you must have done such question before. Next, sodium and copper have work function this and this, then the ratio of the threshold wavelength, you directly know it's c by lambda naught is equal to phi. So the ratio of the threshold wavelengths, lambda 1 naught to lambda 2 naught would be inverse, that would be phi 2 by phi 1, that is 4.5 upon 2.3, that is approximately 2:1. This is the same question, I had done it I think 1 or 2 days back, maybe in NEET or maybe in JEE main paper, so it's a repetition of that one. Next, it takes 4.6 eV to remove one of the least tightly bound electron, that is phi, basically you can write. This is phi. When monochromatic strikes the metal surface, electrons with kinetic energy from 0 to 2.2 eV, that means K max is 2.2 eV because electrons go from any energy from 0 to K max. What is the energy of the photons? Energy of the photon, you know, is equal to what we can write, energy of photon is basically K max plus phi, that is what we write. So 2.2 plus 4.6, so that is 6.8 eV. So it's an easy one, just interpret what it is written and just tick. Next, 31st, a soap bubble of radius r is blown up to form a bubble of radius 2r under isothermal condition. Okay, if sigma is the surface tension of the soap solution, the energy spent in the process will be. So what will we see first? What is the initial area? Because it is soap bubble, I'll take the double. So it was 8 pi r square into s. So this was area. So effective area. So that energy, that surface energy was s into 8 pi r square initially. Similarly, finally, because it is 2r, so it will become 16 pi, it is 2 pi, 4 pi into 2r ka whole square into 2, that is 8 pi into 2r ka whole square, that will become 32 pi r square into what we can write surface tension S. Here it is sigma is written, I have written S, no issues. So the change in energy is 32 minus 8, that is going to be 24. So we'll go for 24 pi sigma r square. Directly you can say that is the delta U. Okay, S is sigma, so you can convert that way. Next way, 32nd. There are two identical small holes of an area of cross section A on the opposite sides of a liquid of density rho, and the difference is height. As tank is resting on a smooth horizontal surface, the horizontal force which will have to be applied to keep the tank in equilibrium. So it's a standard case, you know, whenever the liquid moves, it exerts a thrust force which is equal to rho a v square. So here the first force, that would be, because liquid is going here, so that F1 would be exerted backwards, that would be equals to rho a into v1 square. From the second, it would be in the opposite direction, it would be rho a v2 square. So net force acting would be F1 minus F2, because F1 is more, so that is rho a v1 square minus v2 square. You know, v1 square would be this h1 and this would be h2, so v1 square is equal to 2g h1, this is 2g h2, and you are given the difference, so h1 minus h2 you know is 2h, so it is rho a 2gh. So this is the net force, and this force you have to apply in the opposite direction of the resultant of these two, so value you need to rho a gh. Directly you can say. Next one, the man's near point is 0.5 meter, far point is 3 meter. Okay, power of spectacle lens is required for reading. Reading is done for the nearby objects, so you have to shift what you have to normally you have the nearest point is 25 centimeter. So if the object placed at 25 centimeter, the image should be at 50 centimeter. You can have to do. So you need to find the focal length for this. So what we write, 1 by v minus 1 by u is 1 by f. So what we have, 1 upon minus 50 minus 1 upon minus 25 is equal to 1 by f. So what we have here, plus 1 by 25, this will be 1 by 50, that is f. So f is 50 centimeters, so power would be 100 by f in centimeter, that is equals to plus 2d. For the nearby glass, you know it is plus 2d, so we are left with two choices. Okay, now for the distant objects, what you have, the object is at infinity and you need to place it at 3. So what we will have, 1 upon minus 3 minus 1 upon minus infinity, that goes, that is 1 by f. So f is minus 3 meters, so power is minus 1 by 3 diopters. So we'll go for option C, that is the appropriate one. Next, 34th. A ray of light is incident normally on a glass slab of thickness 5 and refractive index 1.6. The time taken to travel by the ray from source to surface of the slab is the same as to travel through the slab, the distance of the source from the surfaces. So because time taken in slab will be equal to distance is 5 upon speed. Speed is 3 into 10 to the power 8 divided by 1.6, because refractive index is given. So that is 5 into 10 to the power minus 2 in SI units I can write, into 1.6 upon 3 into 10 to the power 8. This is seconds required. So this would be equal to, if the distance is, let's say, d, here the speed would be 3 into 10 to the power 8. So cancelling it, what is d? 1.6 into 5, that is 8 into 10 to the power minus 2 centimeter we will get in SI units, or 8 centimeter, and it would be 8 centimeters. We do need not to convert that, but we had converted, no issue, 8 centimeter would be the answer. Next, particle of mass 5 units is moving with uniform speed this in the XOY plane along the line this. The magnitude of the angular momentum, it will remain same because speed is same and it is moving along the line. What is the line? Y is equal to x plus 4. So if x is 0, y is 4. If y is 0, x is minus 4. This would be like this. Okay, so I can find out this r perpendicular from here. How can I find out? If you see, this distance is 4, this distance is 4, this angle would be 45, this is 45, this would be 90, so this will be also 45. So because this distance, what you know, is 4, so we can make out this distance r perpendicular would be equals to 4 by root 2, just by basic trigonometry. Maths student can do by some other formulas as well, but you can do by this. This is the r perpendicular and this is the velocities line of action, so L would be mvr perpendicular, so 5 units, v is 3 root 2 units, r perpendicular is 4 by root 2 units, so 3 4s are 12, 12 5s are 60 units. Go for option B. You must have done such questions, I suppose, so you can do that. Next, Ring starts to roll down the inclined plane of height h without slipping. The velocity when it reaches, so you know that velocity would be root 2 gh by beta, because pure rolling is being done, and for ring beta is 2, so it becomes root gh. So go for option D. This beta is a very important factor. I'll take some time this in revision classes to help you understand the power of this beta thing. Next, the 6 volt Zener diode shown in the figure has negligible resistance and a knee current of 5 milliampere. Okay, the minimum value of R, so that the voltage across it doesn't fall below 6 voltage. So it doesn't fall below 6 voltage. Okay, so in the limiting case, if I say this voltage is 6, so this means this voltage is 4. Okay, so this 4 means the current through it would be 4 by 50. 4 by 50 means, if I write in milliampere, it would be 4000 by 50, that is 80 milliampere. Now it will have a knee current of 5 milliampere, that means 75 milliampere goes. So 75 goes through this. 75 into 10 raised to power minus 3 into R should be equal to 6. So R should be 6 upon 75 into 10 to the power 3, that is 1000. So now what we have, 75, if I do this, 25, this is 3, this is 25, 40, this is 2, this is 80 ohms, that is the value that I am getting. So this is option C is the appropriate one. Next one. The voltage gain of an amplifier stage is 100. The gain expressed in dB is. So what we said, the dB, and in the dB you write it as 10 log of the value, that is 10 log of 100. Log of 100 is 2, so it is 20 dB. That is what you can write it in the terms of dB. Okay, so this is the way you will write it. Next, a bubble is at the bottom of the lake of depth h. As the bubble comes to surface, radius increases 3 times. If atmospheric pressure is equal to L meter of water column, then h is equal to, okay. So why the radius of the bubble increases? We assume the temperature to be constant. Air is packed inside. So initially the pressure there was P naught plus rho g h into the volume, which was 4 by 3 pi r cube. That will become P naught into 4 by 3 pi triple, that means 3r whole cube. So what we can write, P naught plus rho g h is equal to, from here you can write it as 27 P naught. So what we have, P naught, I can write it as rho gl plus rho gh is equal to 27 rho gl. So what we have now, we can get the value of h as 26L. That is what we can write it from here. So we'll go for option A. Good question. Next, the time period of oscillation of a simple pendulum is this, length of pendulum is this, time period is this, percentage error. This is the question for error. So we know G is 4 pi square L by T square. So from error analysis, you know delta G by G would be delta L by L plus 2 times delta T by T. So substituting this, delta L is 0.01 upon 10 into 100%, directly do in percentage. 2 delta T 0.02 by 0.5 into 100. Okay, so what we have now, this would be 1 by 10, 0.01 by 10 into 100. So 100 is 1 by 10%, so 0.1%, and this would be what we have, 0.0224, 4 upon 0.5, that is equal to 8%. So it comes out to be 8.1% as per me. So what should I go for? I'll go for 8%. That is the most appropriate one. I can't go for none of these. This option shouldn't be there, otherwise that there's a confusion, but I'm going with 8% here. 41. Spherical wavefront shown in figure strikes a plane mirror. Reflected wavefronts will be. Now the best way is draw the ray diagram. It will go like this, and similarly, so it goes like this. So draw the perpendiculars like this. It would be this, like this. It would be like this. So going by this, only option which is looking like C is the appropriate one. This is the best way of looking at it. Otherwise, what you say, this is the reaching first, so it will be reflected first, and similarly the reaching later will turn later, or better it's to draw the ray diagram. Wavefronts will also be always be perpendicular to that, so you can understand from that. Now the 42. The Young's double slit experiment intensity at a point is 1/4 of the maximum intensity. The angular position of this point is. So what we say, I at any point I write it as I max cos square phi by 2. That is what we write. So this is 1/4 is equal to cos square phi by 2. So that means cos phi by 2 is equal to half. So phi by 2 is equal to what we write, and that is 60 degree. So phi would be equals to what we can say 120 degree. That is what we can write, that is equals to, it is half. Okay, so phi by 2 is half, so 60, so phi would be equals to 120 degree. So 120 degree would be 2 pi by lambda into delta x, and delta x is what you write as d sine theta. So that would be equals to 120. I can write it as 2 pi by 3. So this goes. So that sine theta thing would be equals to what we have, lambda by 3d. So as per the options, what is the closest one? It is the C that I can go for. Next, a tuning fork of unknown frequency makes 5 beats with the vibrating string of a piano. Okay, that means 256 and 5, either it is 251 or either it is 261. Now the beat frequency decreases to 2 when the tension in the piano string is increased. When the tension increases, speed increases, so that fundamental frequency of piano increases. So piano's frequency increases. For example, if it is 261 and it further increases, I should write it like this. It's not the right way I've written. The higher one should be written above, the lower one should be written here. So if it was 261 and frequency increased, then the gap will also increase, but here it is decreased, so 261 is wrong, so it was 251, so I'll go for 256 minus 5. So the C option is the appropriate one. So this is the way we do the beats question. Next one, stationary source emits sound waves f frequency towards a stationary wall. Observer moving with speed u in a direction perpendicular to the wall measures the frequency like this. Okay, so observer, where it is moving with speed u in a direction perpendicular to the wall. Okay, at the instant shown, then the u is related to the speed of sound vss. Now so if you see, because source and wall are at rest, the frequency received by wall will be same, that would be same as f, and now wall would be the source and observer will be the observer. So this is at rest, observer is moving, and if I see, the sound is emitted by this particular point P. So along the line joining the component of u, this angle would be 60. So what I can write, this f dash would be f, because source is at rest, it is v, observer is moving towards it, so that would be v plus u. What I can say, right, it is equal to u cos 60 degree. Yes, so what we have, f dash is given as 11f by 8, it is equal to f v plus u by 2 upon v. So f and f get cancelled, so what we get now, 11v is 8v plus 4u, so 4u is equal to 3v, so u is equal to 3v by 4. So that is what we are getting. It is moving with the 3/4 speed of the sound speed. It is very high speed, but it is moving, let it move. Last one, body of mass 2 kg thrown up vertically with this kinetic energy. If g is this, the height at which the kinetic energy becomes half of its original value. Okay, so kinetic energy, we know speed at any height is v square is equal to u square minus 2gh. So if I multiply by half m v square is half m u square minus, this becomes mgh. That is what we have to do. So it becomes half, so half m v square is 245, half m u square is 490 minus m is 2 into 9.8 into h. So 19.6 h is equal to 245. So h comes out as 245 upon 19.6. So if I do this, it would be, if 250 by 20 if I would done, that would be 25. So it would be closer to 25. No other option is match. It is exact 25, I suppose. So this is 25 meter. Go for option C. So this was today's paper. I'm again saying I have attached a type form here. Fill that form to get the PDF of this paper solved by me. This complete PDF I'll send you by the evening. Okay, and I'll be sending only to 50 first persons. After that, that form might not work for anyone. So do remember that. Thanks for watching. Keep sharing the channel. Thank you all once again.